at motion in one dimension. That what does it mean, motion in one dimension? So basically, we will first look at what is motion. What is motion? What is motion? Basically, motion means whenever the body, if a body changes its position with respect to its surrounding. For example, you are walking, right? You're moving from one place to another place, right? Your surrounding is being changed. So it means that you are in motion, right? It means you are in motion. Now, second is what is now rest? If a body does not changes its position with respect to its surrounding, then it is known as the body is in rest. For example, you are sitting on a chair. For example, look over here. Let's look at some examples. Okay, here we got a very nice diagram. So let's look at it over here. Okay, as you can see over here, the body, like the house, the tree, and this tube is in rest. Why? Because its surrounding is not changing. But when you were walking or when you were kicking the ball, like surrounding is changing. It means that you were walking, right? And your surrounding is changing. So that's why it means that you are motion, right? So I hope the concept of motion and rest is clear to you and you have studied this concept in your earlier classes too. Right? Now, one thing important to remember is that absolute motion and rest never exist. What does that mean? It means that absolute motion and rest never exist. They are 100, or you can say 100%. Where is the sign? 100% motion, absolute motion and rest is not present. They are present, like we have relative motion and relative rest exist. Now what does that mean? It means, like, according to one surrounding, according to one observer, you are in motion, but according to another observer, you are in rest. For example, let's look at example. Okay, so what does that mean? For example, like we are on earth, like right now you are sitting somewhere, right? But your earth is in earth is moving. It means the earth is, and we are in the earth, we are on the earth, right? So it means we are also in motion. But according to, for example, someone is watching you, according to that an observer, you are in rest because you are sitting on place. But according to sun, the earth is moving. So it means we are in relative motion. According to one observer, we are in a rest. But according to another observer, we are in rest. We are in motion, right? So that motion or that rest is known as relative motion and relative rest, right? Okay, one thing is remember that, like, thing to ponder is that, for example, if you are sitting on a chair, you are at rest, right? But relative to the chair, relative to your surrounding, relative to your surrounding, right? But you are moving with the speed of 36 kilometer per second with respect to sun. Okay, now what does that mean? Okay, what is that? That one thing to ponder is that if you're sitting on a chair at rest, you are at rest, right? Relative to your surrounding, it means that according to your observer, you are at rest, right? According to you are at rest. But according to the sun, like like the same example, we are on the earth and earth is moving in a uniform motion, right? So it's in motion. It means we are also moving. So that related with respect to sun, we are moving. So with the speed of 36 kilometer per second. So that's our speed. So it means that like absolute motion and absolute rest never exist. We all are in relative motion. You are sitting on a place, but still you are in relative motion. You are moving with a speed of 36 kilometer per second with respect to sun. So that's known as relative motion, right? I hope this concept is clear to you about motion, rest, relative motion, and relative rest. 100% that absolute motion never exists, right? So now let's look at what is mechanics. Now we have studied about motion, rest, relative rest. Now what is mechanics actually? Okay, basically mechanics is a branch of physics that deals with the study of objects that are in motion. Objects that are in motion So mechanics is actually a branch of physics that deals with the study of objects that are in motion. Now mechanics is actually divided into two more branches, right? Mechanics is divided into two more branches. So number first is kinematics. Okay, not kinematics, statics. It is statics. And the second is dynamics. Now, statics means, what does static mean actually? Static means something which is in state of rest. That is known as statics. What is that dynamics? So dynamics means that something is moving. It's in motion, right? So in statics, what we deal with the objects that are in motion but are still in a rest. For example, consider this is a block. Consider this is a block, right? I'm not good at drawing, right? Now you have applied force. You have applied force in this direction, and you applied force in this direction too, right? Now what about the net force? Net force will be equal to 0. Why? Because we are providing force from this region and then this region. So obviously the body will be in rest. So motion of objects under rest, like they are in rest, that goes in the branch of statics, which is the branch of mechanics, right? Which is the branch of mechanics. Now we are having is dynamics, right? Dynamics is further divided into two branches, which are kinematics and other is kinetics, right? Now consider that, for example, this is a car, right? This is a car, this is a road, this is its wheels, right? And I have applied force. As I applied the force, what will be the consequences? What will happen? What is actually the result? What will be the result? I don't know about the what will be the result basically, right? What will be the result, right? So if like we apply force on a body, and what will be the consequences? That the consequences of, like, what are the causes of motion? Here a motion is being happened, right? Motion is will take place, the car will move obviously. So what will be the cause of that motion, right? So that cause of motion will be force. So what will be the result? What are the causes of motion? So in kinetics, actually we deal with the causes of motion. We deal with causes of motion. Causes of motion. But what about kinematics? In kinematics, we don't have any interest in knowing what are the causes of motion, what are the factors that influence the motion. Here we deal pure motion. We don't want to know the cause. We don't want to know the what are the causes of motion, that what were the aspects that influenced that motion, right? So kinematics is divided into two. Dynamics is divided into kinematics and kinetics. So in kinetics, we basically see the causes of motion, what thing cause the motion. But in kinematics, we deal with the pure motion. We don't have any interest knowing that what are the causes of motion, right? I hope this is clear to you, right? Okay, then we are having, when I said motion in one dimension, motion in one dimension, right? What does that mean? Motion dimension means that if you are moving, like we are having three coordinates, right? Out of three coordinates, only one coordinate is changed. Out of, like, this is the simplest definition which I can make. Out of three coordinates, only one coordinate is changed, right? Coordinate is changed. It means that you are moving in one dimension. What does that one dimension mean? One dimension means that you are moving in straight line. Straight line, or you can say you are moving only in one axis. You move in only in only one axis, right? You only move in one axis. For example, we are having three axes, right? Right, this is known as x-axis. This is known as x-axis. X-axis. This is y-axis, and this is known as z-axis, right? So these three coordinates, or you can say three axes. So when you move in only one axis, that is known as motion in one dimension. For example, you are moving. It doesn't mean that you can only move in x-axis. For example, you are moving in. Okay. For example, you are moving in this direction, only in this direction. It means that you are moving in one dimension. For example, if you are moving in, for example, you're moving in this direction, like this, right? So you're moving in one direction. It doesn't affect that you are moving x-axis, y-axis, z-axis, or whatever it can be. So you are just moving in one axis. That means that you are moving in one dimension, right? For example, over here, like for example, motion number one is x, I. X is like I is the I coordinate 1. It is a vector, right? Then here we are having y, j, 1, and it will be also this vector. Then if you are having this z, k, 1, right? This is the motion number 1, right? But what happened actually, what about motion number 2? If a body has covered a motion, it has moved, for example, x, I, now is 2, and is also a vector, plus y, j, 1, right? Plus z, k, 1. Sorry, just like that, right? And it is also a vector. Now look, here it was x1, y1, z1, right? All were the same. But what happened here? Here we are having an x-axis, so x, y, 2. Like it has moved in one direction. As you can see, y, z is same. But what is changed? X is changed. It means the body is moved in one dimension. The body is moved in one dimension, right? So it means body has moved in one direction. So when a motion in one direction means a body moves in only in one direction, that can be x, y, z, or whatever it can be, but it will be only one. So I hope the concept of motion, the motion in one direction, the branches of motions, mechanics, relative motion, relative absolute motion is clear to you.